Okay, what if you could learn literally anything 10 times faster? Imagine acquiring a complex new skill or, mastering a dense subject in just a fraction of the time it normally takes. And no, we're not talking about cheap gimmicks or shortcuts here. We are going to look directly at the actual biology of how your brain acquires, processes, and retains information. It's all about strategically working with your brain instead of constantly fighting against it. Welcome to The Explainer. Today, we're going to strip away all the so-called hacks and look at a real, evidence-backed framework from cognitive science. We're going to see exactly how we can fundamentally accelerate the way we absorb information. It's going to be a real game changer.
All right, let's dive into our roadmap for today. We're purposefully using a technique called chunking to prevent overwhelming your working memory, so we've broken this down into 4 logical phases. First, the ultimate meta skill. Second, optimizing your brain's hardware. Third, the mechanics of memory. And finally, techniques for rapid mastery.
Phase 1. The ultimate meta skill. Honestly, learning how to learn is the highest leverage skill in existence. It is the absolute ultimate competitive advantage in our fast-changing world. So, the very first step is diagnosing your learning type. You have to know what you're dealing with, right? Memorizing a history timeline or new vocabulary is factual knowledge, and that requires an entirely different strategy than procedural skills, like writing code, hitting a tennis serve, or playing the piano. You've got to diagnose the learning type before you dive in. Moving right along to Phase 2, optimizing your brain's hardware. You absolutely cannot learn effectively if your biological hardware isn't primed and ready to go. These are your absolute non-negotiables. Sleep, that's when learning is actually consolidated into your long-term memory. Aerobic exercise, it physically produces a protein called BDNF that sparks the growth of new neurons right in your hippocampus. You also need a totally distraction-free environment for encoding. Varying your study context creates new memory cues. And taking frequent breaks, that brilliantly leverages what's called the primacy and recency effect, giving your brain way more beginnings and endings to remember. Okay, Phase 3, the mechanics of memory. This right here is the absolute meat of this explainer. Let's look at how memory actually works.
Here's a crucial point. Your working memory has a rigid biological limit. It could only hold about 4 to 7 chunks of information at any given time. That's it. So to manage cognitive load, we must break complex material down into small, bite-sized pieces. Once a piece becomes automatic and shifts over to your long-term memory, only then do you add the next layer.
To lock those pieces in, we use something called retrieval practice. Listen to this. Actively trying to recall information is 2 to 3 times more effective for retention than just passively rereading your notes. You know that feeling of struggle when you try to pull an answer from your brain without looking? That mental friction is exactly what strengthens the neural pathway and the memory itself. And this perfectly illustrates spaced repetition. To make a memory truly durable, the material needs to be reviewed at increasing intervals. Think day 1, day 3, day 7, day 14, and day 30. Reviewing it just as the memory begins to fade is far more durable and effective than cramming it all into one single exhausting day. To put into perspective just how powerful this is, medical students regularly use spaced repetition flashcard apps like Anki to flawlessly memorize over 20,000 complex medical facts. 20,000! It relies entirely on leveraging the exact timing of when the brain is about to forget something and then reminding it just in the nick of time. Now, what's really interesting here is interleaved practice. This means intentionally mixing up different topics or problem types within a single study session, instead of just mastering one thing before moving to the next. Now, interleaving definitely feels harder and a bit slower in the short term, but cognitive science proves it is dramatically better for long-term retention and actually applying that knowledge to new situations. Then we have dual coding. This is pairing verbal information with visual representations. Actually, notice how we're pairing my verbal narration with the structured text on your screen in this very explainer? That is dual coding in action. By processing information through multiple pathways simultaneously, your brain basically encodes the memory twice.
All right, let's move to our final section, Phase 4, Techniques for Rapid Mastery. Let's see how this all builds into the advanced strategies used by world-class accelerated learners.
First up is the Feynman technique, which is essentially teaching to learn. Try to explain the concept as if you were teaching it to an 8-year-old. When you do this, you instantly identify where your explanation gets vague or complex or circular. That friction points directly to a gap in your own understanding. So you just return to the source material to fill that specific gap. Next is deliberate practice.
Researchers like Anders Ericsson in his book Peak note that systematically attacking your weakest sub-skill is exactly how true experts are made. Instead of just practicing generally, you identify your weakest specific sub-skill, practice it in total isolation, get immediate feedback, and then relentlessly find the next weakness and repeat the whole cycle.
When you combine deliberate practice with these mechanics, the results are mind-blowing. For instance, Scott Young completed the entire curriculum of a 4-year MIT computer science degree in just 12 months. And Benny Lewis? He learns conversational languages in a mere 3 months. Unbelievable, right? But these are the direct results of applying highly structured, accelerated learning techniques.
A key part of their success is totally overcoming Parkinson's law, which states that work expands to fill the time available for its completion. By setting really aggressive, compressed deadlines, you prevent Parkinson's law from taking over. It forces you to focus entirely on the critical 20% of the material that actually yields results, creating a sense of urgency that sustains motivation.
As we wrap up, take a look at this comparison. The generation effect conclusively proves that information you actively create, like writing your own summaries, drawing diagrams, or answering tough questions, is remembered significantly better than information you just passively receive, like simply reading a textbook or watching a video.
So there you have it. You now have the complete, evidence-based science of learning. But hey, to avoid cognitive overload, try picking just one single principle to apply this week. Build a solid habit out of just one of these techniques first. So which one is it going to be? Make sure to subscribe for more evidence-based explainers, and let's keep learning.